For my fourth instructional tutorial, I've chosen an application called MathDisk. So I'm going to type in MathDisk and pull it up. And within MathDisk, my target audience on this one is going to be a little bit higher level. It's probably going to be an upper level math classroom, which would be calculus level or above. And this is probably a little bit more difficult type of an app to use than the normal math classroom teacher at the lower levels would want. There's an excellent tutorial right here, if you listen to it, that tells you a lot of things that you can do with this. And I'm going to scroll down here just a little bit, and I'm going to go to where it says Natural Math here and click on this link, and it pulls up a drop-down menu over here of several different tags. And again, I'm going to go down to the one that's Calculus right here, and then I'm going to go over to Area of Integration. And what Area of Integration is, if I click on this, is, I'll wait for it to come up here. What we're looking at is we want to know what's the area of this curve underneath of this curve from -2 to +2 on the x-axis, and which would go up to 4 on the y-axis. When you square 2, it's 4. When you square -2, it's also 4. And when you get into integration and calculus, the actual answer to the problem is 5.333. And what we're looking at on this is finding the area of each one of these individual little rectangles here, trapezoids, and trapezoids right here, to be able to do this. So again, right here we have the number of intervals available, and when we show 25 right here, it gives on each one of these right here, it's 5.35, 5.35, 5.427, and 5.35 given at 25, and we know the actual one's 5.33. If we change the number of intervals, as you see, the rectangles get, if we go smaller, the rectangles get much larger, and if we actually go down to 1 on this one, the length here would be 4. The height would actually be 4 as well. 4 times 4 is 16, which you see here, here, and here. As we go up the other direction, as high as we can go with the intervals, which is up on 50, which puts many, many more rectangles on each individual one, or trapezoids on the yellow one down here. And we're going to go up to 50. And when we're at 50 right here, again, if we find the area of each individual little rectangle right there, add all of these together, we are now on the right sum. On the right sum, we're at 5.338. On the left sum, which is the green one, we're also at 5.338. On the trapezoid, we're at also at 5.338. And on the midpoint rule, we're at 5.357. So each one of them is getting very close to the 5.333 one that we were looking for. And again, I think this would be an excellent tool when we're introducing integrals, right sum, left sum, midpoint, and trapezoid, to be able to show the students exactly what we're talking about in terms of the rectangles, and how as we stay approaching infinity, we get closer and closer to the answer, which is 5.333. I'm going to click off of this one, and I'm going to go back, and we're going to take a look at the solid of revolution here. And also, again, within calculus, a lot of times you need to be able to draw three-dimensional stuff for the kids to actually get a view of what you're looking at here. And so again, we're able to click on it and turn and look at our, if we had z minus 1 times the quantity z minus 1 squared, and we wanted to integrate that and look at what our picture is, we have this available. Again, this would be so much easier than trying to draw this out on some type of a whiteboard or something and actually have the kids be able to see what we're talking about. So again, this is a much more advanced tool than the other ones that we've looked at so far. But at the same time, I think this could be a very important one to bring into the classroom. Again, the target area would be upper level math students, and probably would be it. I probably wouldn't share it with the other teachers unless they were upper level math teachers. So again, this concludes my fourth one, and thank you.